All right, guys, can you guys hear me online?
Yes, loud and clear.
All right. So the structure of this course, so it's going to be very interactive. I want you guys to ask me questions. Okay, a lot of the stuff that I say is going to be pretty easy. You know, I say it one time, I explain it one time, you guys will understand it. There's going to be things that I'm going to go over that I can repeat 3-4 times and some people won't understand it. Okay, and if some people don't understand, that means a lot of people don't understand it. So I really need you guys to ask me questions, whatever it is that you don't understand, right? I want you guys here in the Virginia campus, just raise your hand. If you guys are online, just use the message, the instant message tool, the chat tool over here, okay? To ask me questions, I make it a point to look at this chat window every couple of minutes for any questions, okay? Because if you're not understanding something, then I'm not doing my job. I need to make sure that you guys understand what I'm going over, okay? And I have no problem explaining things over again in different ways, okay? So I need to know if you don't understand something. So ask me questions, okay? A lot of the questions that I'm going to be asking you guys to make sure that you guys are paying attention, you guys are staying awake in my class, which is going to be kind of hard sometimes. You know, a lot of those questions that I'm going to ask you, they're going to be interview questions, okay? In fact, most of the questions that I'm going to ask you are going to be potential interview questions, okay? There's going to be weekly assignments that are going to be due the following Saturday after the Wednesday when the work is assigned. The following Sunday when after the work is assigned. So homework is going to be posted up on the forum. I'm going to show you all that at the end of class today, where to go find it. All of my notes are also going to be up there on the forum, and I'll show you where to go find those later. All the homework that you're going to be submitting will be submitted to this email address, homework@peopleintech.com. Now, if you have any questions when you're doing the homework, when you're reviewing the class material or any of that kind of stuff, okay, the very first thing I want you to do is Google, okay? And the reason I say this, you need to make Google your best friend. The reason I say that is when you're on the job, right, and you're faced with a situation that you haven't seen before, or you're not really familiar, you're not really understanding what to do, right? Your only solution at that time will be to Google, okay? You're going to have to use Google at that time, okay? And if you're not familiar with Google, if you're not fluent with researching different things on Google and figuring out what the answer is, then it's going to be very hard for you, okay, at that time, okay? So you can, you know, email me, you can ask your friends and all that, and I have those are second and third steps here, okay? But the number one thing that you need to be comfortable with is Googling and figuring out what the answer is, okay? That's really important that you do that, okay? That you're comfortable with Googling things and figuring out what the answer is, okay? So if you have a question, Google it, okay? If you still can't figure out what the answer is, then, you know, talk with your classmates and your friends, okay? See if they can help you out. And then finally, as a last resort, email me, okay? I'm not doing this because I don't want to get your emails or anything. I just want you to be able to be self-sufficient, okay? I can answer your questions. I can easily give you the answer, but if you understand the answer, if you go through that process of figuring out what the answer is on your own, that'll help you when you get that job, okay? It's going to be frustrating right now because you got to spend that time trying to figure out what the answer is, okay? But that whole process, you'll hone your skills in researching and things like that, okay? And that's going to be very important. There's going to be quizzes, not so much in class labs, but quizzes and tests that are going to be almost regular throughout the class. There's going to be a 5-question quiz every other Wednesday, okay, and that's going to cover basically the material that we've covered up till that point, okay. There's going to be some tests here and there as well. More when we get into the automation testing, there's going to be some more assessments at that time, okay. Make sure that at this point, if you haven't already, that you have access to the People in Tech forum, okay. Because once you get access to the People in Tech forum, you also get access to the recorded videos. So all these classes that are here, they're all being recorded, Okay, so if you do miss something or if you're not able to attend for one day, you can always go back and take a look at those videos. So make sure that you get registered and you get access to the forum and the videos and everything like that. All of my homework, all of my notes, everything will be posted up on the forum. Okay, so it's important that you get access to that. Okay. Any questions up till now on anything? No.
Yeah. So the class every Tuesday or Wednesday. So
Yes.
Wednesday you will post the homework.
Yes.
You will due by Sunday.
It'll be due by that Sunday, by that following Sunday. Okay. And I'll explain how you're gonna be submitting your homework online to that email address, homework@people1tech. Okay. All right. So we have some basic questions. What is software development? Who are the people that are involved with software development? What do they do? Right? We need to know exactly what software testers do. That would be nice, because you're trying to get a job as a software tester, so it'd be good to know what to do, right? You also need to know why is software testing important? What's the big deal, right? And how is software development done? Okay. So what is software development? This is the process of developing software through successive phases in an orderly way, right? Now this process, this cycle, software development life cycle, right? This includes the following phases. If we're going to do software development, we have to write some sort of programming code, right? We've got to use some programming language like Java or C++, things like that, right? So some code has to be written. Preparation of requirements and objectives. What are requirements? This is what the software is supposed to do, right? What is it supposed to do? Is it supposed to be able to allow customers to pay for items that they selected, right? Are we able to, send messages through this application to other people, other users? What is it supposed to do, right? That's what the requirements are. Okay, so we got to prepare those requirements. We have to design the software, right? So before we actually code that software, before we actually use or create that programming code, we have to sort of design it and sort of see what's going to happen on each page of that application, right? Where the different images going to go, where the links on the web application going to go, right? All that stuff has to be designed, right? How is one part of the application interacting with another part of the application, right? All of these things need to be designed, so that's going to be part of the software development lifecycle, right? Confirmation that what was developed has met the requirements. So if the requirement says that two users are allowed to communicate or should be able to communicate with each other, right? Then we got to make sure that two users can communicate with each other, right? So we have to make sure that those requirements, those things that were asked of the application, that they're being met, right? Releasing the finished software to the customer or to the client, right? That obviously after we develop it, we have to give it to our customer who we developed it for, right? We have to do some sort of planning, right? We have to know, how long it should take, what the budget's going to be, right? How we're going to do the development, how we're going to do the testing, all that kind of stuff. We have to plan out all these things, right? So we got some planning that's involved in here. And then finally, providing some support to the customer after releasing the finished software. So once we develop the software, right, we have to support it because the customer doesn't know right away how to use that software, right? They could come across some issues, right, in using the software. They could do something wrong and cause more problems, right, if they don't use the software properly. So we have to sort of provide some training. If there are some issues there that they've created, then we have to sort of help them through that, right? So we have to help them maintain the application. Once we deliver that application to the client, to the customer, then we have to sort of help them and maintain that application for them. Does that make sense? Right? All right. So overall, on a high level, these are the phases of the software development lifecycle. These are the things that would happen within the software development lifecycle, in the software development world. Okay, but they're kind of out of order right now. Okay. Are there any questions here at this point? Anything that you think is missing?
Where is the test to fit in this?
Where would the testing come into this? So confirmation that what is developed has met the requirements, that's software testing right there. Okay? If the client asks for an application that allows two users to communicate, but we're giving them an application that allows users to purchase items, did that meet the requirements? No. So we got to test. We got to make sure that two users can communicate, right? We have to make sure that what the client asked for is actually being met. So when we're actually testing, and I'm going to get a little bit ahead of myself, but when we're testing, we're actually testing against the requirements. Okay, so that's what that is. This is not clear. Okay. I'm not sure what to do about the lists.
Muted.
Okay. All right. So now we sort of put the whole thing in an order. Okay. Can't see that. That's not good. Okay. All right. So this is overall what the software development lifecycle looks like. Okay. Now, right off the bat, I'm going to tell you, do not memorize the names of these different phases. Okay. Do not memorize the names of these different phases. And the reason I'm saying that, and you'll see a little bit later in this presentation, the software development lifecycle, the SDLC, is presented in many different ways online. Okay, many different ways. Over here we have 7 phases over here. Okay, you'll see if you Google this, you'll see an SDLC with 5 phases, or 4 phases, okay, or 6 phases, right? The names for those phases can also be different. Okay, so don't get bogged down by the number of phases, by the names of these phases. Instead, understand what's happening within the life cycle and when it's happening. Okay? And that's more important. Is that clear? All right. So the first thing, requirement gathering. We're going to start over here on the bottom left. And we see under requirement gathering, we have document the business requirements, outline the project scope, and approximate the project estimation. So here we're sort of getting an understanding of what it is that we need to be doing, what the software needs to be doing, right? Does that make sense? We're talking to the clients, right? And we're getting an understanding of what the client wants. Okay, that's what we mean here by requirements gathering. Okay. All right. After we've gathered the requirements, now we kind of have an idea of what it is that needs to be done. So now we can start planning out how we're going to do it, right? In this planning and analysis phase over here. Okay. We're going to, for example, pick out what technologies we're going to use. Okay. How are we going to implement what it is that you guys do? Why can't you? Okay. All right, I'll try to talk a little bit slower. Okay, but this is how I talk, so yeah. All right. So we're going to start to plan out the different technologies. What are the different server architectures that we're going to have? You guys all took the CNSS, right? So you guys learned about the different network architecture, server architecture, all that kind of stuff. Talked about servers a little bit, right? Yeah. Okay. What type of technologies we're going to implement? Okay. Data migration analysis, gap and feasibility analysis. So this last thing right here, gap and feasibility analysis, right? Here we're planning out, we're making sure that what the client is asking for is something that we can actually do. Is it possible? Is it feasible for us to do? Right? Okay, so once we have our planning and our analysis done, then we're going to start designing our software, right? This is where I was talking about, we're going to see where the buttons are going to go, where the images are going to go, where the links on the page are going to go, all that kind of stuff. We're designing how that application on each page, what it's going to look like. How is it going to be designed, right? So all that stuff is being done over here. Finally, once the design is done, then we're going to move on to development and implementation. Okay? So this is where that code is being written by the developers, right? This is where that code is being written by the developers up here. And then after the development is done, then we have testing and quality assurance, right? Okay? So then we have testing and quality assurance. This can only happen after the software has been developed, right? Only after it's been developed can you test what's been developed. Does that make sense? Okay. So yeah, so we have, and within testing, we're going to spend a lot of time here discussing what's going on over here. Okay. But we have many different types of testing that's going on. All right. And then we have what's called deployment and delivery. Right. So here, this is where we're actually going to be delivering that software that's finished. That finished software, we're going to be delivering it to the client, right? And then finally, maintenance and support. Okay. Here, it's been delivered to the client. Now they have to, if they have any issues, we're going to be helping them with it. If they come across any kind of problems, right? We're going to solve those problems for them. We're going to maintain that problem, that application for them. Okay. All right. Let's see. Who are the people that are involved? So we have developers. Obviously, they're the ones that are going to be writing the code, right? We have someone called a business analyst. Okay. These guys, they're going to be gathering and creating the requirements. Okay. We have the testers. That's you guys, right? They're going to verify that the software meets the requirements, right? And then we have a project manager role. Okay. This is the guy that's, overseeing everything, making sure that everyone is staying, within the schedule, within the budget, all that kind of stuff. Okay. Any questions so far? Yeah.
Is there testing after it's rolled out as well?
Testing after?
After the software is rolled out?
Yes, there is, and we'll talk about that. There is testing after it's rolled out. All right, guys, I'm going to ask that you guys, whatever you guys chat about over here, it's related to the class. You're asking questions or talking about the class. Okay, nothing else. All right. As QA, how much interaction do you have with the business users? Where is DBA? Okay. Okay. So as QA, how much interaction do you have with the business users? You can have a lot. Okay. You can have a lot. And when we, because the business users, they're the people that actually understand what they want. Kind of. Okay. They want an application to do certain things. So they know what it is that they need. Okay. You are testing against the requirements as testers, software testers, right? So those requirements, right, would be coming from the client, from the customer, right? So you as testers will be referring to the requirements, okay, to perform your testing, to make sure that that the software meets the requirements, right? But if there's some question that you might have about the requirements, right? If you don't understand something, perhaps, then you will be going to the client, okay? That's one option that you have. Another option is going to this guy, the business analyst, okay? And we'll talk more about that. Where's the DBA, database administrator? So where is the DBA? So DBA is not, database administrator is someone that's a separate role from the development, software development process, okay? They can assist the developers in developing their application because that application will have to work with the database that they are administering, right? They can help the testers because they're testing an application that's sitting on a particular database, so they have to test the database, right? So they can assist the testers in that way to test their application properly, but they're not actually involved in developing the software, okay? So that's why you don't really see a database guy over here under these roles. Under a tester, my responsibility starts from which phase? We'll get there. We'll talk about that. It actually starts from the requirement gathering phase, but we'll talk about that. Okay. Any other questions, guys? No? Okay. So what exactly do you guys do? So our job is to test the application against the requirements, right? That's basically what our job is, okay? So let's say, for example, if we have a requirement that says that valid users are able to log in, right? Here, we're going to have a test called login, right? And we're going to have a couple of steps, right? We want to make sure that valid users can actually log into the application, right? The first thing we got to do, we have to launch the application, right? The next thing we have to do is enter a valid user ID, then enter a valid password, and then click on the sign in button, right? Now if you notice, each of these steps has what's called an expected result, right? So for step one, launching the application, the expected result is that the application is launched and it's available, right? We're expecting that to happen. If it doesn't happen, then it's a problem, right? If we try to launch the application and it doesn't launch, we can't continue after that, right? That's a pretty big problem there, right? Next, step two, enter a valid user ID, right? The expected result here is that the valid user ID is entered, right? Why isn't it that the valid user ID is, that the valid user has signed in at this point? Because we haven't yet entered the password, right? So right now, if we enter the user ID in the user ID field, then the expected result is that the application has taken our keyboard inputs, right? And those letters, those characters are in the user ID field, right? So the valid user ID is entered. Step three, enter a valid password. Here, we're expecting that the valid password is actually entered in the field, right? But we haven't yet signed in. Our expected result at this point cannot be that we have logged in yet because we haven't yet clicked the sign in button, right? So for step four over here, what would be the expected result? Okay, that valid user is logged on, right? Right? Does that make sense, guys? Yeah. So each step is going to have an expected result. Okay. And when a test is executed, the tester performs the steps on the application, and the actual results are recorded. Okay. So here we have the expected results, what we're expecting, what should happen, right? When we actually execute this test, then we're going to take note of what actually happened, right? Does that make sense? So we have expected results and we have actual results for each step. Okay. When the actual results don't match the expected results, that means that we have potentially a bug or a defect. And we'll talk more about these things a little bit later. Okay. So this, by the way, is a test case. This is what's called a test case. Okay. This is not a formal test case. It's not in the right format or anything, but this is basically what it would contain, right? Okay. How do we log the bugs? Like what software? We're going to talk about that next week. All right. Why is software testing necessary? We want to be able to prove to the customer that the application is problem-free, right? See, as we're testing, right, this is a test case over here, right? This will be documented, right? We're going to have a list of all of our test cases somewhere, okay? And as we execute, we're going to say, okay, this login test case passed. That means that valid users can log in, right? We'll have another test case for verifying that two users can communicate, can chat with each other, right? Let's say. Okay, we'll have the steps for that in that test case, right? And when we execute it, if it passes, right? If the test case passes, okay, then we can say, okay, that test case has passed as well. And so we want, the reason that we're doing it is because later on, when we go and deliver the product, when we go and deliver the application to the client, we want to be able to tell them, hey, you asked for this stuff, and we tested this, and so we know that this is valid, and here's our proof that we tested. Does that make sense? We also want to ensure that the product or the application works as the user requested. Again, they've asked for certain things. The client has asked for certain things to be included in this application, right? We want to test to make sure that those requirements that they asked for are actually part of this application. If one of the requirements that they asked for was that two users can communicate with each other, but when we run the test it fails, then that functionality is not working properly, right? Or it might not be there, right? So that's a problem. We can't deliver it to the client yet, right? So we want to make sure that it's working as requested, okay, as the client has required of us. Testing helps increase the reliability of the software as well as improving the quality. So as we're testing, we're going to find what are called bugs or defects, which are basically problems with the application, right? And as we find them, obviously we're not going to be like, oh, look, here's a bug. Okay, here you go. Here's the application. We're not going to do that. We're going to find the bug. We're going to fix it, right? And then only after we fix it are we going to give it to the client, right? So as we're testing, we're finding more and more bugs, more and more defects, right? And so we're fixing more and more of the application, which means that the quality of that application is going up. Do you guys follow?
Then you test it again, like after you fix it.
Yep. And then also to discover defects or bugs and determine the root cause of the issue. So one of the big things about testing, right, you earn your money by finding bugs, okay? In other words, that's why you're getting paid. You're not getting paid to verify that a valid user can log in, because any developer can make that happen, okay? What you're getting paid for, actually, is to make sure that an invalid user cannot log in. Does that make sense? That's a security thing, right? You want to make sure that if you enter in your user ID with my password, there's going to be a problem there, right? Or if you use my user ID and your password with an incorrect password, that's going to be a problem, right? You want to make sure that in those types of instances, those types of situations, the user cannot log in, right? So that's something called negative testing, and we'll talk more about that, okay? But that is where you actually earn your bread and butter, okay? Doing this negative testing, okay? All right. Any questions? No? Yeah.
Why developers, they don't test for their software and they hand over to tester. They can test, right?
Okay. Yes. So question is, why don't the developers do their own testing? Right? First of all, because you need a job. Okay? That's why. Okay. But no, they actually do their testing. Okay? It's just at a very high level and they don't go into too much detail. Okay? Because they have other things that they need to get done. Okay? So that's not really their job. Their job is just to make the application, develop the application. Your job is to test it. And because testing itself is a very, it requires a lot of time and effort. Okay? So either the developers can either test their software or they can develop the software. Okay? And there's actually a reason why developers don't test their own software. We'll talk about that a little bit later on. Okay? But they do, to answer your question, they do a little bit of testing. Okay? But it's not in too much detail. Okay? How often does the app comes out fairly bug-free? So, okay. Generally, you want to give the client bug-free software. Okay, that's from a customer service perspective. That's a pretty good, business plan to have. Okay, that you want to deliver good quality products. Okay, so you're going to be, as part of the testing that you're doing, right? You want to test as much as you can in the time and in the time restraint that you have. Okay. Now we understand, and project managers and clients, they all understand that you cannot test everything, and we'll understand that a little bit later on, why we can't test everything. Okay. But we try to make sure that we test as much of the application as we possibly can. Okay. But we try to make it a point not to let bugs go through into production. Okay. But yeah, we'll talk about how we can prevent that a little bit later on. Is negative testing done separate from the acceptance testing? Yes, that's a different type of testing. I mean, how often bug-free right from the developers? Oh, never. Never. How often is an application bug-free right from right after the developers are done with it? That never happens. Never. Okay, if you test an application for the very first time, I'm going to say this a couple of times actually. If you test an application for the very first time, right, you just got it from the developers and you test it and you find no bugs, right, that doesn't mean the developer did a very good job. That means you've done a very bad job as a tester. Okay, there can never be a time where developers develop an application and there is no bug, there is no problem with it. Never. Okay. All right. So, how is it done? How is software development done? It's done by following a set guideline known as the software development lifecycle. Okay. Now, this SDLC is a process that is followed for a software project, and it's basically a plan that tells us how we're going to develop, how we're going to maintain the application, and how, when the time comes, how are we going to be able to replace or alter or enhance the application, right? For example, Facebook. When it first came out, does it look today anything like it was when it first came out? No. No, it's not. There have been a lot of updates. Every couple of months they roll out with some kind of update, whether it's for the mobile application or the web application. There's always some updates coming out every couple of months, right? So that's all being done, it's all being developed within this software development lifecycle, okay? Is it possible to make the software 100% bug-free? That's always the goal, but that almost never happens. Okay, it's always the goal to make it 100% bug-free, but it almost never happens. Okay. What should we do as testers? We're going to talk about that. What are you going to do when you come across a bug? How are you going to deal with that? We'll talk about all of that. Okay. So the software development lifecycle. The entire development process is broken up into several successive phases. Many phases occur one after the other. Some phases can occur simultaneously. Okay, and we'll talk about how that happens. Okay. Now, this is, again, what I was saying earlier. Don't pay attention to the number of phases or to the names of those phases, okay? Just because when you go and Google this stuff, you're going to find a lot of different variations to the software development lifecycle. Okay, so I don't want you guys to be confused, okay? That in my PowerPoint I have one way, and then online you're seeing 10 different ways. Which one is the right way? Okay, so don't get confused, okay? Instead, I want you to focus on what's going on within each phase, okay? If you understand that, you don't need to know how many phases there are, or what the names of those phases are, any of that kind of stuff. Okay, if you know when the requirements documents are being created, when the design documents are being created, when the test cases are being executed, right? If you know when all these things are happening within the software development lifecycle, that's all that matters. Okay. All right. But we're still going to go through the phases because you need to understand some structure about this. So we have the planning phase, requirement analysis phase, design phase, development, QA testing phase, and production and maintenance phase. Okay. Now already you can see here, this is different from the names that we saw earlier, a couple slides ago, right? So next couple of slides, I'm just showing you different images that I got off of Google about SDLC. Okay. So here we have the feasibility study. Again, making sure that what the client is asking of us is something that's actually possible, if it's feasible, right? this is part of like that planning phase, I guess you can say. Then we have requirements understanding over here, right? Here, again, we're just gathering the requirements, right? We're understanding those requirements, right? Then we're going to start designing that software or that system. Then we're going to start developing it. Then we're going to do our testing. And then finally, we're going to have maintenance. We're going to maintain that application after it's been deployed, right? By the way, you don't see a deployment phase here. We saw that earlier, though, right? You guys see that? That's missing from, that's not missing, okay? That task or that event is just put into the system testing or the maintenance phase. It's just part of either one of these two phases, okay? Here's another example. This is a system development lifecycle. It's the same thing as software development lifecycle, right? So we're developing the concept. This is more along the lines of what the business side would do, right? So we have a business side, which is the client, the customer, right? And then we have the technical side, which is you guys, okay? The assumption is that the business side doesn't understand the technical side, right? They don't know how to develop the application. They don't know how to test the application, right? And then the technical side, you guys don't fully understand the business side, okay? That's the general assumption. That's not always the case, okay? There are going to be individuals in the organization that have a good understanding of both, okay? That's going to happen, okay? But the general assumption is that the business doesn't understand the technical side doesn't understand the business fully, okay? So here, system concept development, this is generally done by their client, by the business side, seeing, you know, what need they have, what business need they have for a particular application, for a particular software, okay? And then, again, planning out everything, seeing if what they're asking for, what the client is asking for, if it's something that's possible, right? Planning out the budget, the schedules, all that kind of stuff is being done over here, right? Then we have requirement analysis, right? We're gathering those requirements. We're getting those requirements, what the client actually wants, right? And then analyzing them, making sure that we understand them. Then we're going to start designing that software, right? Figuring out where on the page the images are going to go, where the buttons are going to go, how one part of the application is going to work with another part of the application. All that is part of this software design. Then development, right? So that's where the coding comes in. The developers are going to start coding their application. Then integration and test, right? So here we're testing, making sure that everything is working fine. And then software implementation over here, okay? So over here, implementation means deployment, means delivering that product, that software to the client, okay? And then we also have the maintenance phase over here, okay? This is a more simple version of the SDLC: planning, analysis, design, development, testing, and then deployment, right? I will go over each one of these phases in detail, okay? I'm just going sort of a high-level overview right now. Told you. Okay. Any questions, though, so far, before we get into the individual phases themselves? Any questions? Okay. All right. Okay, so we have the planning phase. You need to have a plan before you can begin any kind of endeavor, obviously. Planning is the most important and fundamental phase of the software development lifecycle. Who's involved? So we have the senior members of the development team. And here, when you hear me say development team, right, in some places I'm talking about just the developers, right, those people that are doing the coding, right, or like in this example here, I'm talking about the entire development team. That includes the testers, that includes the developers, that includes the BAs or the business analysts, right, as well as the project managers, okay? So this includes everyone in this case, okay? So you're going to have the senior members of the development team as well as the client, okay, that's going to be involved here. And here, information is being gathered in this phase, and it's used to plan out the basic project approach, okay? And we're conducting that product feasibility study. You know, is it feasible? Is it practical? Is it something that we can do, right? The entire project is being planned out in this phase, so we're figuring out what the schedules need to be. Deliverables are being determined. Deliverables are basically what items need to be delivered to the client and when, okay? And then also the budgets are being set here as well, okay? Any questions here? No? Okay. All right. Next thing here is the requirement analysis phase. So here the main contributor is the business analyst, and their main job is to translate the requirements, okay? Now, the BAs, they're going to gather what are called the business requirements from the client, okay? They're going to go and talk to the client, and they're going to get those business requirements, whatever it is that the client wants, right? And then what they're going to do, remember what I said, the assumption earlier, right? Business side doesn't understand technical side doesn't understand the business side, right? The solution to that is this guy, this BA, business analyst, okay? This business analyst is someone that understands the business and also has an understanding of the client. Okay. Guys, do not mess around with that webcam. It actually works. All right. So the BAs, they're going to gather, thank you. They're going to gather the business requirements from the client, right? And then what they're going to do is they're going to translate, or they're going to convert those business requirements into technical requirements, okay? Which is going to be used by the development team and the testing team, okay? So the reason that this needs to happen is because the technical side doesn't understand the business side. More specifically, the business requirement will say something like 2 users need to be able to chat using the software. That's it. But how is that going to be developed? How is that interface going to work, right? The technical aspect of it is not there. The business side can't give you that information. Does that make sense? Right? What is the platform on which these 2 users are going to collaborate on? Okay? That information is not there in the business requirement. That information will be there in the technical requirements. Okay? Because there's so many different ways that this sort of feature or functionality can be developed and designed. Okay? Does that make sense? Think about it. We have Skype, right? WhatsApp, right? iMessage, right? Google Hangouts. These are all chatting features or chatting applications, right? But each one of these things is developed and designed in its own way, right? So that just goes to show that there's many different ways of doing this, right? And any one of these products could be a solution to what this client is asking for. Does that make sense? So it's important that the technical requirements are there, okay, so that the development team, the developers and the testers know exactly how to develop and what exactly should happen when 2 users are communicating with each other, okay? So the BAs are the subject matter experts, SMEs, for the requirements. What does that mean? That means that the subject matter would be the requirements, right? The subject matter, that's what it is, okay? That is the topic, okay? They are the experts on that topic, okay? Subject matter experts, that's what it means, okay? They are the experts in a particular area, okay? They know if you have any kind of questions about anything, you go to them, okay? You go straight to them and you're going to get an answer right away, okay? They are the experts, okay? The reason that they're the experts, the subject matter experts for the requirements, is because they wrote the requirements, right? Does that make sense? You know, some of you guys were just talking about the SMEs over here.
has nothing to do with the tester.
Sorry?
The whole thing is between technical requirement and the PA. It's like both of them is between developer and the PA. They providing them information to do the software requirements of this business. So the tester, what has to do with that?
Well, you need to know as a tester what the requirements are, right? Because remember, you're going to be testing against the requirements.
Okay.
Does that make sense?
Yeah.
Right? So you have to also understand what the requirements are. So you need to know what the technical requirements are. Okay? Any other questions? Yeah.
So business analysts, since there are multiple industries, are there subject matter experts on different industries?
Yeah. So subject matter expert, SME, is something, it's more of like an honorary title. It's not an official title anywhere, okay? It is understood that that an SME or a SME, they're called different ways, okay? These are the people that really know what they're doing, okay? You can have an SME in networking, in cybersecurity. You can have an SME in software development, and even within software development, development using Java, development using C++, Python, whatever, right? So there's many different areas in which someone can become an SME, a subject matter expert. Subject matter expert, all that means is that, you know, they really understand what it is. Now, just like you can have within different areas of IT, you can have different SMEs in different industries, banking, retail, healthcare, government. You can have different SMEs there as well. Yeah. Okay. All right. All right. So a little bit more about what exactly happens in this phase, in this requirement analysis phase. So first thing, BA is going to meet with the client. They're going to gather the business requirements. Okay. Then the BA then defines and documents the business requirements and gets the final approval from the client. Okay. Once the client approves the BA's work, the business analyst was going to create what's called the business requirement document, which is more of a formalized document, right? And this BRD is approved by the project manager. Okay. After the project manager approves it, then the business analyst is going to start converting those business requirements into technical requirements. Okay, and those technical requirements are going to be placed in what's called this SRS, Software Requirement Specification. Okay. Basically what's going on here, right? The BA is going to go and talk to the client. Okay? They're going to sit down, the client's going to say, I want this, I want this, I want this. Okay? At that time, the BA is taking notes. Okay? He's asking questions, right? So he has all these notes that he got from this meeting, right? And there could be multiple meetings, okay, to gather these requirements, okay? At the end, right, when all these meetings are done, right, and all the questions are answered, right, then what happens is the BA now has a bunch of notes, right, about what the client wants, okay? Nothing is formalized right now, okay? So what he does is he takes those notes about what the client wants and puts it in a document called the business requirement document. Okay, and it's a little bit more formalized. He polishes the language, makes it, makes the language proper and everything, right? Now he takes this business requirement document and he takes it back to the client. And he's like, hey, did I get this down right? Is there anything that's missing from here? Did I get anything wrong? Right? Once that client said, hey, yeah, this is exactly what I wanted, right? You're good at taking notes. This is exactly what I wanted. Then he's going to come back and he's going to start converting those business requirements into technical requirements. Okay? And those technical requirements will then be approved by the project manager and the other managers that are there on the team. Okay? Before the developers take a look at it, before the developers start working on it. Okay? Does that make sense? You are like, what the hell does that mean? What was your question?
No. You're right, yeah.
You sure?
I felt like the developer is going to work on it first before the manager look at it.
No.
Okay.
They won't start, they can provide some feedback, right, on the technical requirements, but they will not start developing until those requirements have been approved. Does that make sense?
The client also give the time frame also, like in this time frame I need my software.
Yeah, the client can request the time frame, okay? But think about it. If you're, let's say let's take construction for example, okay? Forget about IT, forget about software for a little bit. If we're talking about construction and you want to build a house, okay? You're the client, okay? And you tell the builder, I want this, I want this, I want this, and I want you to build it in 1 week. It might not happen in 1 week, right? So you can say I want it in 1 week, but then the builder is going to come back and say, all right, we can't do it in 1 week. There's no way, and no builder can do it in 1 week, okay? Maybe a month, maybe 2 months, right, at the very earliest, right? And that's if we get a lot more people to come and, help out or something. Maybe 6 months is the normal time or something like that, right? So you can request, as a client, you can request that it be done in a certain amount of time, okay? But then remember that feasibility analysis, right? Is it possible to do it in that time frame? Maybe, maybe not. We have to determine that, right? Okay. So BRD and SRS. These are the two documents that are coming out of this phase, okay? Business requirement document, software requirement specifications, right? BRD, those are the business requirements. Those are the non-technical requirements, okay? Those are the requirements that the BA got from the client, right? Once the BA has those business requirements, then he's going to convert. He's going to translate those business requirements into something that you, the testers, and the developers can actually understand and work against, right? Those are the technical requirements. Those technical requirements sit on this in this SRS, Software Requirement Specifications document. Okay? Any questions here? Yeah.
So when the tests are going to work, after developer or after BA analysis?
So we'll talk about when exactly the tester is going to start working. There's actually something called the software testing lifecycle, which we'll talk about either today or probably next week. Okay? So you'll get an understanding of when you're actually going to start working. No, non-functional and functional requirements we'll talk about in a little bit. Examples of these requirements, we'll give them out as we're actually going to practice creating some of these requirements later on. Okay, analyzing these requirements, we're going to do that. Okay. All right. So here, this image, right? It's actually pretty old, but it gets the point across. So the reason that I'm showing this, right, is to really get an understanding of what actually happens, okay, as this software development lifecycle progresses, okay. So over here, this first one, how the customer explained it. This is what they wanted, okay. So how did that project leader understand it, right? How the system analyst designed it, right? How the programmer, the developer wrote it, right? That doesn't work out. How the business consultant described it. So we have a couple of different roles that are being talked about over here, right? Yeah, don't get bogged down by that, okay? The business consultant here, this is probably like the representative of the business, okay? And what they actually want and things like that. How the project was documented, it's like no documentation here, right? What operations were installed, what was actually given, right? How the customer was billed, right? how it was supported, how was it maintained. There's almost no maintenance here. And then this is what the customer actually needed. Okay, they just needed a tire swing. Okay. Now, this is somewhat funny, okay, but this is actually quite accurate, okay. A lot of times, the business, the clients, they don't actually know what it is that they want or what it is that they need, okay. They really don't, okay. They don't know what technology is out there that can help them get their job done, okay. So they don't always have a good or a clear understanding of what it is that they need, okay? So they'll tell you something like this, okay, when what they needed was something like this, okay? For example, let's say you're in the manufacturing industry, right? And you have a client that comes to you and says, hey, I want you to build me a jumbo jet to get from Washington, D.C. to Baltimore. Right? You, as a manufacturing company, could build a jumbo jet for them, and you can charge them for that jumbo jet, right? Or you can consult with them. You can talk to them and say, hey, listen, man, I know you want to ride in style and everything, but you don't need a jumbo jet to get from D.C. to Baltimore, right? You can make do with a nice car, right? Think about it. If you, as a business, take this client for a ride and say, yeah, we're going to build you this plane and we're going to charge you, $20 million for it, right? They might pay for it, but then when they realize that they didn't actually need a plane, do you think they're going to come back to you for some other business? No, they're not going to trust you, right? Right? So from a customer service perspective, right, you want to make sure that you're being upfront with the client. You want to make sure that you're, as time goes on, as the project goes on, that you're educating the client on what it is that they're getting, what it is that they need, right? Does that make sense? Right? Okay. All right. So next thing here, we have this design phase, okay? And here, the main contributors are the developers, the BAs, and the PMs. Actually, you know what? Let's take a break here. Yeah, let's take a break here, okay? And we'll come back and start here again.
Okay, mister. Can you take it like 8:30?
Oh yeah, well I know we'll do that. I'm gonna stop at I think what is it, 8:30, right?
25.
Okay. That's fine. That's fine. I'm gonna stop in time for that. Don't worry. Let's come back, guys. 7.
Yes.
Windows always has that's also the reason why it's like messed up because I haven't had an antivirus on there in like 4 years.
All right, guys. Can you all hear me okay now? Online, can you guys hear me?
Yes, loud and clear.
Okay. All right. So let's get back to this. Okay. Okay, yeah, we should be fine. Okay. All right. So the design phase. Over here, the main contributors would be the developers, the BAs, and the project managers. Over here, what's going on here? Okay. So over here, the developers are planning out their work. Okay. We had a planning phase already, right, for the entire SDLC, for the entire software development lifecycle, right? There, we were planning out the budgets and the schedules, seeing if it's possible for us to move forward with this type of application, right? But here, this design phase, this is where the developers are actually planning out not what they're going to develop, but how they're going to develop, okay? It's based on the requirements, on the technical requirements, right? And based on those technical requirements, the developers are going to come up with many different design approaches. Okay, they're going to come up with different solutions for meeting those requirements. Okay, and each developer, right, or each team of developers will come up with their own sort of design. Okay, how they want to create this application, right? And those are going to be considered what's called the Design Document Specifications, the DDS. Okay, DDS. Here, these are documents that are based on various parameters, right? So they're looking at, risk assessment. They're looking at product robustness. How, what is this application going to encompass? What business features is this application going to be encompassing? Design modularity, how many different components of this application are there going to be, or is there going to be just one big system? Okay, they're going to be looking at the budget and the time constraints and all that as well as they're designing this application, right? And so all these different developers or these teams of developers, they're going to come up with these different designs, different possible designs. Okay, and out of those multiple designs, the best one is going to be chosen. Okay, a design approach clearly defines all the architectural modules of the product, along with its communication and data flow representations with external modules. So this design document, right? This is not just talking about where the images are going to be, where the buttons and the links and all that kind of stuff is going to be on the page, but also what happens when you want to have one part of the application interact with another part. When you want to click on one button and go to another page, what page is going to be going? What page is it going to go to? What's going to show up on that page? How is that page going to look like? All that kind of stuff is sort of, being worked out and planned out in this phase. Okay. A blueprint is created that's going to show how the various servers are going to be working together. So you have all the different app servers, the web servers, database servers, load balancers, all that kind of stuff. Okay, how are they all interacting with each other? How are they all set up? Okay, you also have what are called wireframes or mock-ups that are part of the DDS documents. Okay, and this is what the Facebook wireframe. Okay, this is what it looks like. Okay, this is what a wireframe in general looks like. Okay. So you can see here, generally images are boxes with X's in them, right? We have some links over here, some more images over here, right? That's a smaller image. This is a bigger image, right? This is what Facebook looked like a little while ago. I don't know if I think it's still like this. I usually use the Facebook mobile app, so I don't know much about the web application. Okay, but this is sort of a high-level design, high-level blueprint of what this application, what Facebook, this particular page is going to look like. Does that make sense? And this is part of those design documents. Okay. Any questions on this design phase?
Yeah, what is the architect? Because design is, architect doing the design, right? Then after that goes to the developer. They are doing the coding.
Mm-hmm.
So in that way, so you said the developer, BA, and PA.
Mm-hmm.
So where the
so that architect, right?
Like you just said that the one frame for the Facebook, it says like here's one box, here's the other, or the logo, it's left or right, right?
Mm-hmm.
So that's who are doing this? Developer?
Developers will be doing this with the input from the BAs, the project managers, with the input from the BAs and the project managers as well.
So
okay, and now
architect is not doing anything.
that architect, right? In many companies, that architect is some sort of a subject matter expert on the development team. Does that make sense? So that architect's job may not just be, designing different applications. Okay, it could involve designing the application, right, as well as actually doing some coding, because they're actually a developer. Okay, at their core, they're a developer, but they're also, because they're so, they're at a much higher level, right, in seniority and experience and all that kind of stuff. So they're working at an architect level, okay, but they're also doing some development as well. So when I say developers, I don't just mean people that are doing the coding, okay. It also includes, you're right. It also includes those architects. It could include the database developers. DBAs can be part of this as well if they're providing some sort of input on how the database needs to be structured and all that kind of stuff, right? So there's many different people, but these, at its core, we have developers, BAs, and project managers that are involved in this phase. Okay, does that make sense?
Yeah.
All right. Okay. And now we have the development phase. This is where the actual development of the software product begins. So up until this point, no development has been done. Okay, a developer has not started coding anything yet. Okay, until this phase begins. Okay. Here, the developers are going to use those technical requirements that are found in the SRS, right, the Software Requirement Specifications document, as well as the DDS. Okay. They're going to use these documents as a guide to know what and how to develop the application. They're going to use programming code, using languages like Java, C, C++, Python, all these different languages. This programming code is going to be generated using these languages, and it's going to be generated based on those technical requirements, okay, based on what the client actually wants. Now, the developers need to follow some coding guidelines that are defined by their organization and some programming guidelines that are they're set forth by the actual programming language that they're using. Okay, so for example, Java is a case-sensitive language, right? So the application must be developed with this restriction in mind. The developers need to keep that restriction in mind as they're developing. Okay, so an uppercase A and a lowercase a, they mean two different things in Java. Okay, so developers need to be aware of these things as they're developing. Okay, the organization, they're going to want something called classes. You don't need to know what this actually means, but they're going to want that all their classes to follow a set naming convention. Okay, a class is a feature of Java programming. Okay, so each class will have a particular name. Okay, what that particular organization will have a set format for naming their classes. Okay, a set way to name all of their classes, so that there's uniformity throughout the code. All the code looks similar. Okay, so the developers will have to keep in mind these different organizational requirements for their coding. Does that make sense? All right. Now the programming language is chosen based on the needs of the software being developed. So there's pros and cons of using Java versus PHP versus C, C++, C#, all these kinds of things. Okay. And so the developers, the development team will pick the language that they need to implement, okay, to get the best results for that application based on the requirements and the needs of the business. Okay. Any questions here? All right. QA and testing phase. Guys, I plan to give break around 8:20, the dinner break, so if I start to go over, just let me know, okay? All right. So here, obviously, the main contributors will be the testing team. Now, once that code is developed by the developers, the application is tested against the requirements, okay? Testing against the requirements, what does that actually mean? So it ensures that the product is actually solving the needs addressed and gathered during the requirement analysis phase. Okay, so we're trying to make sure that that product, that application that was developed, right, actually is meeting the needs that were set forth by the requirements that were described in the requirements documents. If the client requested that only customers who have paid can access the application, then we design a test case that's going to verify that only paid customers can access the application, right? So the requirement was that only paid users can access the application, so we're going to create a test to verify that, okay? Testers design test cases which contain those test steps, and they're going to link them to the requirements, okay? They're going to link them to the requirements to prove to the client that the requirements they asked for have been met, okay? And requirement traceability matrix. So we're going to talk about what this requirement traceability matrix is all about. When we start talking about ALM next week, we're going to actually show how to link a test case with the requirements, okay? Basically, think about it like this, okay? The requirements, the business side, they know what the requirements were. They know what they asked for, right? As testers, we need to, as the development organization, when we deliver the application, we need to be able to tell them, hey, this is the product, right? And everything that you asked for is present in this application. We need to be able to say that to the client. Does that make sense? Now, how are we going to prove to the client that everything that they've asked for is actually present in the application? Because in order for them to know that, they would have to go into the application and see if all these different requirements are being met. In other words, they would have to do their own testing, right? But they're paying us to do it. Does that make sense? So how do we prove to the client that what they asked for, right? In other words, the requirements is actually present in the application. How do we prove that? We're going to prove that through this thing called the requirement traceability matrix, okay? This is simply, and I'll show this in a few minutes, probably when we come back. But this requirement traceability matrix is simply a table, okay? And it lists all of the different requirements that the business asked for, okay? And it has all the different test cases that we have that are testing the requirements, right? Because remember, we're testing against the requirements, right? And when a test case passes, right, that test case is linked to a requirement, okay? We're just going to put a check mark there, or we're going to say that it passed or something. We're going to somehow notate that it passed, okay? And this way we're going to go down the list of requirements, and whenever there is a test case that's linked to it that has passed, we'll mark it, okay? And whenever we have a test case that's passed, right, and that's linked to a requirement, right, when that test case passes, that means that requirement is present, that functionality is present in the application, right? Does that make sense? So by having this requirement traceability matrix, we're able to present to the client a document or a table showing that these are the things that they asked for, these are the test cases that have passed that tested if these things are present in the application, therefore what they asked for is present in the application. Does that make sense? Kind of, sort of? Okay. We're going to see this in a few, I think later today, the requirement traceability matrix. Okay, but it's very important that we link our test cases to our requirements. Okay, we're going to take a break at 8:20. All right, so we have many different types of testing. So we got functional and we have non-functional testing. Functional testing determines if the application is working, if it's functioning the way it's supposed to, right? Within functional testing, we have different types of testing. We have something called unit testing, which is what developers do actually. This is that testing that the developers do. Okay, this is called unit testing. There's something called integration testing, regression testing, system testing, acceptance testing, and there's many others. And I have a whole other presentation on all these different types of testing. Okay. There's also something called non-functional testing. Okay, here we know that it's working fine. We want to know how well is it working though. Okay, determines how efficiently the application is working. So we got things like performance testing, stress testing, load testing, as well as security testing. So yeah, so for example, with performance and stress and load testing, right? We're going to talk more in detail about what these things are, right? But basically, we know that it's working properly. We know that a user, when they enter a valid username, a valid password, when they click on the sign in button, they're going to be signed in, right? That's working fine. That functional test has already been done, right? When we want to do performance testing or stress testing, what we're trying to see is how many users can log in at one time, okay, before the application crashes, right? That's somewhat of a load test, for example. Okay, so we know the functionality is there. It's working fine. Users can log in, but how many users can log in at the same time? Okay, that's what this non-functional testing is all about. Okay, that's one example. Okay, any question here? We're going to spend, obviously, we're going to spend a lot of time on this part. Yeah.
If I say the customer requirements are already met, but I found some different defect on the software, do I need to work on it or just let it go?
Okay. Yeah. So there's something called testing scope. Okay. So the question is, you know, I've been able to test against all the requirements, all those test cases have passed, but I found a bug that's not related to any requirement. Is that what your question is? Yeah. Okay. I found a bug or a defect, some sort of an issue that's not related to any of these requirements. What do I do in that situation? Okay. So there's something called testing scope. Okay. And what that means is, what that defines, and we'll talk more about this a little bit later, but this testing scope, what it defines is what exactly you're going to be testing. Okay. How far into the application are you going to go? Okay. And that scope is determined based on how much time you have, how many resources are available to do the testing, right? How complex the application is, how complex the requirements are, right? That's what's going to determine. There's many other factors that determine the scope, the testing scope, okay? But that testing scope is going to be there, okay? So if what caused you to find these bugs was within the scope of testing, right? Then they're valid bugs, and you should, and we'll talk about how we're going to log them and get them fixed, okay? But if you found those bugs by going outside of the testing scope, then it's not a concern right now. Okay, and we'll talk a little bit later on how we're going to deal with that type of stuff too. Okay. Yeah, Obamacare is a very bad example of performance and load testing. That's right. Okay, when the Obamacare website went up, it was bad. It was really bad at that time because they did not properly performance test that website. Okay, and the result was that when the website went live, right, when Obamacare website went live, everyone tried to go and get their insurance, okay, and the application crashed. Okay, that's what happened 4 or 5 years ago when Obamacare came out, right? It was a huge disaster, okay? All right. Okay, production and implementation phase, also known as the deployment phase. So here, the testing has been done. The development has been done, right? Now, the software developers have developed the application. The testers have tested the application. We now have good quality software, right? Now it needs to be delivered to the client, and that's what this phase is all about, okay? Once the application has been successfully tested and all the issues have been resolved, then the product is delivered to the client, right? So this means that as you're testing, you're going to find those bugs and those defects, right? Those bugs and defects have to be fixed, right? And then after they're fixed, they have to do some more testing to make sure that they're actually fixed, right? So once all of that testing is done, now we have that good quality software, and now we can deploy it. We can deliver it to the client, okay? As soon as the product is deployed to the customer, they're going to first do something called beta testing, okay? Beta testing. what this beta testing is, no, I have in another presentation I have more about what this is. But basically, this is where a small number of end users, right, a small number of clients, that is those users, those end users, they're going to be looking at the application, okay, and they're going to try to use it and see how it is, if it's working fine, if it's not working fine, okay. So that's what beta testing is. So once it's deployed, the very first thing that they're going to do this beta testing, okay, just to make sure that there's no issues with the application. If there are any changes that are required, or if any bugs are found, then the client's going to report them to the development team right away, okay. Once the changes are made and the bugs are fixed, then the final deployment will happen, okay. All right. And let's see, maintenance phase. So this is the last phase here, the last thing here. So basically what's happening here, the application has been deployed, right, to the client. The client is using that application, right, but they come across some sort of an issue, let's say, okay. There's different levels. So what's going to happen is this application is going to be deployed to the client. That client, that organization will have, okay guys, give me a few more minutes. We're going to finish, okay? So that client at their organization, right, they're going to have an IT help desk, okay? If a user has some issue, right, they're going to go and contact that help desk. And the help desk will be able to resolve many of those problems, okay? Does that make sense? If there's something that the help desk cannot solve, then they're going to contact the development organization, right? The testers are going to look at and see what the problem is. If it's a valid problem, right, then they're going to, they're going to create a bug for it, and they're going to have the developers fix the problem at that time, okay? But that's all that's happening here in this maintenance phase, okay? Any issues that come up, those issues are being fixed, okay? If there's any updates that the business wants to have, right, over the years, Facebook has been updated quite a lot, right? Those are all enhancements. That's all done in this phase, in this maintenance phase, okay? Any questions here? All right. Okay, guys, so let's do our dinner break here. Let's see. Let's come back, guys, at 9:20. Guys, I'll see you. All right, guys. Let's get started again. Where that sound is coming from, can you please mute it? All right. Still not good. We good now? No, we're not. We're good now? No, we're not. We're good? Good. Okay. So up till now, we've covered the software development lifecycle, SDLC. Does anyone have any questions regarding the SDLC? Software development lifecycle. We're going to go into more detail about how this is actually implemented in terms of testing, what's going on in that testing phase, the different types of testing. We're going to go into a lot more detail. This is just sort of like a high-level overview of what this development lifecycle, software development lifecycle, is all about. Okay. No questions? Okay, so I got some questions. Yeah, I got questions too. So what? Let's see. What happens in the requirement analysis phase? In the requirement analysis phase, what's going on in that phase?
Figuring out what we need for the software.
Figuring out what we need for that software. Can you elaborate on that? Gather. Okay, so in the requirement gathering phase, we're going to gather the requirements.
Like what does it need
Right.
to do?
But what does that mean? What's going on in that phase, though? Who is?
What the clients are looking for.
Sorry?
What the clients are looking for.
We're figuring out what the clients are looking for, right? Who is the main contributor? Who is the main actor in this phase? The BA, the business analyst, right? The business analyst. And what are some of the documentation that's being generated within this phase?
First the PRT, then SRS.
Okay, so first the BRD, then the SRS, business requirement document, right? And then the SRS, software requirement specification. Which one is the technical requirements? Which one are the SRS is the technical requirements, right? Okay. And BRD is the business requirements, the non-technical requirements. Okay, great. Let's see. So you are given, let's see, to test an application, right? You're working as a software tester, right? To test an application, what type of requirements do you need? Do you need the business requirements or do you need the technical requirements?
Most is technical.
Technical. Okay. In order to create test cases, right, which we're going to learn how to do, okay, but in order to create test cases, right, you have to have the technical requirements, okay. You can create test cases against the business requirements, okay, but to fully test every single aspect of the application and how it works, you need the technical requirements. Okay, going back to that example of that platform where two users can communicate with each other, can chat with each other, right? It's not enough to know that two users are able to communicate with each other. User A sends a message to user B and user B gets the message, right? That's fine, right? But along with this broad requirement that two users should be able to communicate with each other, there are underlying requirements. Requirements that the business might not think of right away. For example, security, right? The message that I send should not be able to be intercepted by anyone else, by a third party, right? So to ensure that that message isn't intercepted by a third party, there's on the back end, right? On the part of the application that the user doesn't necessarily see, but is still, you know, what makes the application work, right? That part that's running in the background, okay? There's going to be functionality that's developed, okay, to ensure that a third party can't access that communication. We have to make sure that that third party cannot access that communication. This type of requirement would not be listed in a business requirement, right? But if this is not tested, right, then can we go to the client and say, hey, this software that we've developed for you is bug-free, issue-free, there's no problems with it, this is exactly what you're looking for. Can we go to the client and say that? No, we can't, right? Because we know that we didn't test this one aspect about the software, right? We have to first make sure that whatever the client wants, that they're getting it, right? But then also we need to make sure that there's other things that the client hasn't thought about yet, right? But we're incorporating into that application, okay? Does that make sense? Okay. All right. Okay, so let's see. You are, let's see, what else? Okay. When do you know that you might have a bug or a defect as you're executing your test cases? Sorry?
When you log in, it's filled, like you cannot log in the software.
You cannot log in
Like detected software.
Like if you use a valid username and valid password and then you're not able to get in, that might be a problem.
Okay.
Like when the expected result doesn't happen, like unexpected.
Okay. So your answer was the closest answer that I was looking for. I don't want specific examples. Okay, like the login test that we were talking about. I'm asking more in general terms. How do we know when we're executing a test, right, if our test has passed or failed, or if that step has passed or failed?
Make it a testing doesn't match with expected.
That doesn't match the requirement.
How do you know that it doesn't match the requirements?
Because we will get the requirement.
Say that again?
We do get the requirement.
Right. So we have the requirements, right? And what are we comparing it to?
Negative testing?
Very simple answer. I think you're thinking too much into this. Okay. How do we know if a test step passed or failed? How do we know that there is a potential bug or a defect?
When we're not getting the expecting result, that we're looking for.
Okay, when we're not getting the expected result.
So that means it's not working.
Okay.
Some defect.
Okay.
In whatever the software is there, we got to open it.
Say that again?
First, we have to open the software and see what's going on. Expected versus
Result varies from the
What did you say?
expected versus
Expected versus actual results. That's what I was looking for. Okay? When the expected result doesn't match the actual results. Okay? When the expected results doesn't match the actual. What is the expected results? Where is that expected results coming from? From the requirements, right? Because remember, we're testing against the requirements, right? We're testing against the requirements. So that expected result is coming from the requirements, right? We have to compare that requirement, what we're expecting, with what we're actually seeing, right? Does that make sense? All of you guys were dancing around expected results, okay? I was looking for actual results as well in your answer. So I'm going to do this from time to time. I'm going to ask questions all the time, okay? But even though I know exactly what it is that you're saying, right, I'm going to want to expect that you say the right thing, okay? Because in the interviews, they're going to expect you to say the right thing. Does that make sense? Okay? So don't take it personally or anything. I will say that you're wrong, even though I know exactly what you're saying and I know that you know what you mean, right? But half the battle in the interviews is saying the right things. Does that make sense? Okay? So my job is not just to teach you how to do software testing, but also to help you get that job. Okay? That's why you're here. Okay? You're here to get that job. Okay? So I'm trying to also prepare you for those interviews as we go on. Okay? So don't take it personally. Okay? I know a lot of you guys understand what I'm talking about, but when it comes to repeating what I'm saying or to regurgitate some answer, right, that is difficult at times. Okay? So, yeah. Okay. Let's see. All right, cool. So we have, I have a couple of other PowerPoints other than these two here. So I'm going to go ahead and start with this. Software development methodologies. And this is quite long. 47. So what I'm actually going to do, okay, we're going to talk about some of the more predominant and widely used development methodologies. I'm going to upload this PowerPoint to the forum so you guys can take a look at it on your own. Some of the methodologies that aren't so widely used, I'm going to skip over, okay? But you can go back here and take a look on your own, okay? All right, let's see. Software development methodologies. So are we sure? We have no other questions on software development lifecycle? Yes? Everything is crystal clear? Kind of, sort of? Okay. So we're now going to talk about these things called software development methodologies, right? And these are just different ways that the software development lifecycle is implemented in different organizations, okay? So we're going to see those phases that we just talked about, right? Planning, requirement analysis, design, development, testing, deployment, and maintenance, right? We're going to see those phases implemented and actually used in different ways, okay? Those phases will still take place, okay? But how they take place, when they take place, all that kind of stuff, that's a little bit different, okay? Based on these methodologies. So what are software development methodologies? Development methodologies are the various processes which can be selected for the development of a project depending on the project's goals. Okay, so based on what that project is, right, there's going to be different ways that the software development lifecycle, the SDLC, will be implemented. Okay, the selection of a specific methodology has a very high impact on the testing that's carried out. And you're going to see, based on what we understand today about the different methodologies, you'll see how they vary. Okay, and you'll be able to tell the difference there. Okay, and you know, if you pick, if there's a waterfall methodology versus an agile methodology, they're two very different things. Okay, and the results will also be different. Okay, and waterfall and agile, these are just two different methodologies that we're going to talk about today. So the development methodology is going to define the what, the where, and the when of our testing. Okay, so based on that methodology, is going to be our testing. Our testing is going to, focus on that specific methodology. Okay, it's going to influence the various types of testing that we're going to have to do. Selection of a specific methodology will also help us determine which testing techniques to use. And we're going to talk probably next week about different types of testing and different testing techniques. Development and testing are carried out in various ways depending on the methodology chosen. Okay, so based on this methodology that organization is going to implement, development will take place in a certain manner. Testing will take place in a certain manner. Okay. So here we have a list of some of the development methodologies that are in use today. We have what's called a waterfall methodology. We have V-model, incremental methodology, RAD, agile methodology, iterative methodology, spiral methodology, prototype methodology. Okay. So this is just a small list of methodologies. Okay. Some of the more predominant ones, the ones that are used most often in the real world, would be waterfall and agile. Okay. Waterfall and agile. These are the two most widely used methodologies. Okay, and you'll see as we go more into it, within agile methodology, there's different variations, different flavors of agile as well. Okay. All right. So waterfall methodology. By the way, guys, I don't know if I think I saw a couple people earlier. You guys don't have to write this stuff down. I'm going to be posting these stuff on these PowerPoints up online for you. Okay, so you guys can just download them from the forum. Okay. Okay. Waterfall methodology. Each phase of the software development lifecycle must be completed before the next phase can begin. So in other words, before we can begin the testing, the development must be completed, right? Before we can deploy the application, right, the testing must be completed. What did I say? No, I messed up. Before the testing can begin, the development must be completed. Right? Before we can deploy the application, the testing must be completed. Right? Yeah, that's right. Okay. So each phase must be completed. Each phase of the software development lifecycle must be completed before we move on to the next phase. Right? Waterfall is good for these types of projects. If it's a small project, or if the project, or where the project, all the requirements for that project are well known. Okay. And they're not likely to change. See, remember that picture that we had about the tire swing and the swing with the tree and all that, right? So in the beginning, the client, or actually a better example would be the plane, the plane going from DC to Baltimore, right? So the requirement, business requirement initially is that they want a plane, a jumbo jet from DC to go from DC to Baltimore, right? Then as we educate them, we consult with the client and we tell them, hey, you don't really need a plane. Then they're like, okay, that's fine, let's go for a car, right? Now what kind of car, right? So the requirement changed from a plane to a car, right? And then we're getting the specific requirements for that car. It needs to have navigation, it needs to have, 4 doors instead of 2, right? It needs to be all-wheel drive, whatever, all these different specifications about a car, right? So these requirements are constantly changing because the client, right, doesn't always know what they need or what they want. Okay? Does that make sense? So waterfall is a good idea when the client knows exactly what they want, right? And when it's fairly simple, when it's a fairly small project. Okay? At the end of each phase, a review is going to take place to determine if the project is on the right path and whether or not to continue or discard the project. So at the end of, let's say, the development phase, we're going to review everything, right? We're going to make sure that the development was done fine, right? We're going to make sure that they followed the technical requirements, not by mistake the business requirements, right? We're going to make sure that the design was good, right? All that kind of stuff. We're going to look at everything up to that point and then decide if we need to move forward, right, with the testing phase. Once the testing is completed, right? We're going to go back and we're going to review the testing that was done. We're going to look over the results, make sure that the results are accurate, right? And we're going to see if there was any major issues that were found with the testing, right? Let's say we were testing in the wrong environment, let's say, or we tested using the wrong data, right? And that threw off our results. Then we need to go back and we need to do the testing again, right? So we're going to go back at the end of each phase. We're going to review the work that was done, okay? And when we decide that everything is good, right, then we'll move forward with the next phase of the software development lifecycle. Make sense? Here in Waterfall, the SDLC phases do not overlap each other, okay? So first thing, we got planning. When planning is completed, then only do we move on to requirement analysis and gathering, right? When that phase is completed, then only do we move on to the design phase, right? When the design phase is completed, then only do we move on to the development phase, right? And so on and so on, okay? Testing here starts after development has been completed, obviously, because we need to have something to test, right? We can't test anything unless it's actually been developed, okay? So this is why it's called a waterfall model, a waterfall methodology, okay? We start off up here, requirements gathering, okay? Then we have the design, then the implementation. See, over here, implementation means development. Earlier in a previous slide, we saw implementation, and that was actually deploying it to the client, right? So these words are interchangeable, okay? And they're, so don't get confused by that. Okay, here implementation means development. After the development, then we have testing, then we deploy the system, and then we have the maintenance phase. So only after the requirement analysis is done, then can we begin the design phase. Only after the design phase is completed, then do we move on to the development phase or the implementation phase, right? Only after the implementation phase or the development phase do we begin testing, right? And so on and so on. Okay. Any questions up to this point, guys? No? Okay. Yeah.
Who will take care of the maintenance part, like the testing, like if something wrong with the software? So
What? Okay. So,
like if crash or anything happen, like so, who's back to testing department again, or the maintenance guy will take care?
Okay. So what happens in the maintenance phase? That's basically what your question is, right? So after the application has been deployed, right? Now it's time for if you bought a car, right? You need to go. Usually, what they do if you buy a new car, they give you like a year of free oil changes, or 2 months of service or whatever, things like that. That's what their maintenance is, right? That's their car maintenance, okay? If anything goes wrong, there's also a warranty that goes along with almost anything that you buy, whether it's a car, a laptop, or whatever, right? If anything goes wrong with it, then you send it back to the manufacturer, right? And they'll fix it, and they'll give it back to you, right? Same thing here with this maintenance phase, right? When you deploy and you deliver a software that was developed, right? You have to maintain it, okay? And so if the user comes across any kind of issues, okay, then the first thing that they're going to do is they're going to try to solve it themselves, okay? In other words, remember I told you that there's going to be like a help desk type of a help desk department in that company's organization, in that customer's organization, right? So for those customers that maybe forgot their password, right? They can't log in because they're not able to figure out what their password is. They went on vacation for 2 weeks, they come back and they forgot their password, right? They have a help desk for that. That doesn't mean, just because they can't log in, doesn't mean that there's a problem with the login functionality, right? It just means that they forgot their password. They have to reset their password, right? The help desk at that organization will deal with these types of issues, okay? Now, if it's something more serious, they've reset their password, or they're trying to reset their password, but the system is not letting them reset their password, right? That resetting the password, that functionality, there's some problem there, right? Then what's going to happen is that help desk is going to contact us, the development organization, right? That help desk, a member from that help desk team is going to contact the development organization, and they're going to talk to the maintenance team, or the production support is what it's called. Okay, production support. Okay, production support team. Okay, they're going to contact that production support team. That production support team is going to try to fix the problem right there. Okay, if they can. Okay, if they can't, they're going to let the testers know and say, hey, look, this issue is in production. Okay, by the way, production just means a live application. Any website that you might go to, right? Facebook, Yahoo, Gmail. These are all in production right now because they're all live, right? So the production support team, they're going to come back to the tester and say, hey, this issue got through to production. Okay, go ahead and try to verify that it's an actual issue and send it on up to the developers to get it fixed. Okay, so now the testers are going to see, they're going to try to recreate that problem, right, in their environment. They're going to try to see what the problem is, okay, and then they're going to inform the developers of that problem. Developers will fix that problem, right? The testing will be done for that, and we'll get into this whole, what this whole process is, but the developers will fix the problem, right, and that update or that enhancement will be delivered to the client, okay? And that is basically what's happening in this maintenance phase, okay? Make sense? Okay. For the waterfall model, do you guys have any questions on this? Yes, no? Okay. So we got some advantages of waterfall. It's very simple, okay, and it's very easy to understand and use. It's easy to manage due to the rigidity of the model. So each phase has specific deliverables and a review process, okay? In this model, the phases are processed and completed one at a time, and they don't overlap. Waterfall model works well for smaller projects where the requirements are very well understood. But there are some disadvantages. Once an application is in the testing stage, it's very difficult to go back and change something that was not well thought out in the concept stage. So let's say the design, remember the design phase? That design was flawed. There was a big problem in the design phase, but no one realized it, right? So after the design phase, we have the development phase, right? Now that software was developed according to that flawed design, right? That improper design. The development was done based on that improper design, right? Now when we test, we're testing against the requirements, right? So the requirements were fine, but the design was messed up, right? So now there's going to be huge problems that we're going to find in our testing phase, right? Now, what's the solution? We have to go back and we have to fix the design, right? Because that was where the problem is, right? The design was flawed, so we have to fix the design. Now, when we fix the design, now we have to go back and develop the software again, right? Because now we have a new design, right? We have an updated design, and so we have to update the code as well. Do you guys see a problem there? If there's a problem that's not caught early on, right, and that problem is continued throughout the rest of the phases, right? When it comes to the testing phase, that's where a lot of these problems are found, right? We now have to go back to the design phase, or maybe even if the requirements were wrong. If the requirements were flawed, that could also happen, right? Then we have to go back to the requirements phase, right? And start all over from there, from that point on, okay? So that's a huge disadvantage in the waterfall methodology. If a problem is found, right, it's very possible that we have to start over again, right? No working software is produced until late during the life cycle. Let's go back up here. Requirements gathering and analysis. There's no product that's there for the client to see at this point, right? Then we have the design. Again, still, at the end of this phase, there's still no product. There's still no software that was developed that the client can see and sort of feel and navigate through and provide feedback with, right? Implementation or development, right? Again, it's just being developed. It still hasn't been finished yet, so the client cannot see it. Over here in the testing phase, this is where some sort of working software is present, finally, right? Only at this stage, only at this testing stage, okay? Way down here in this waterfall methodology, okay? What if, when we come out over here at the end of the testing stage, right? Towards the end of the testing stage, there's a type of testing called user acceptance testing, UAT, okay? We'll talk about that next week, okay? This is basically where a representative from the client comes and looks at the application, right? The user comes and looks at the application and see if they are willing to accept the application the way it is or not. That's why it's called acceptance testing, right? They're looking at it, making sure everything is working fine based on their requirements, what they want to see in the application, right? Only at that time will the client or some representative of the client be able to see that working software, right? Only at that time will they be able to provide any kind of feedback about the application, right? What if they don't like what they see? Then what? Then we got to stop, we got to go back over here into the development phase, maybe even the design, or maybe even the requirement analysis phase, depending on what they say is the problem, right? So no working software is produced until late during the life cycle. Do you guys understand why this is a huge disadvantage of the waterfall methodology? Yeah. High amounts of risk and uncertainty. Again, this ties back to the fact that there's no working software, okay? Because only at the end of the testing phase is the client able to see what's going on or what's been done up till now, right? You know, let's say if this was a 5-year-long project and we're in a waterfall environment, waterfall methodology, then, you know, 4.5 years later, only then does the client see what the result is, what that product is, right? That's a long time, right? That's why waterfall methodology is good for small projects, okay? Projects that can be done within a couple of months, 6 months, less than a year, right? Okay. It's not a good model for complex or object-oriented projects. So again, if it's a big project or if it's a very complicated project, that means that if it's a complicated project, that means there could be changes to the requirements, right? Because as you start developing, you start realizing, oh, wait, hold on, I can't do it like this. I got to do it like this, right? And if I had to do it like this, then this component over here needs to go away, and instead of that component, we need to have this component, right? So as we're developing, as we're designing this product, as we're developing this product, we ourselves are actually learning what we can and can't do, what this product, this application can and can't do based on the requirements, right? So the requirements can be changing from time to time, okay? So if it's a more complicated application, right, then waterfall methodology is not a good idea, okay? Poor model for long and ongoing projects. Do you guys understand why? Right? You guys understand why for waterfall we cannot have a long-term project, right? Because we need to be able to show the client something in a short amount of time. Otherwise, we're wasting all that time. If at the end of that, the client comes back and says, "No, I don't like this. Do it over again," right? Also, it's not suitable for projects where the requirements are at a moderate to high risk of changing. So again, if you think that the clients are going to come back and say, no, I don't want a jumbo jet, I want a car, right? You don't want them saying that when you're attaching the wings, right? At that point, it's gone a little too far, right? Does that make sense? So, you know, if you think that the requirements are going to be changing, then waterfall methodology is not the right way to go, okay? Give an example of a project that's going to take 4 to 5 years to develop. Let's see, well, if we as QA are doing most of our work during testing phase, what do we do during the other phases? So that's another problem, okay? Mohammed Mehdi, you bring up a very good point there. You're a tester. You're working as a software tester, right? Making $50 an hour, right? Are you doing anything here in the requirements gathering phase? Not really. System design phase? No. Development or implementation? No. Testing? Yeah, you're working your butts off over here, right? Deployment? Not so much. Maintenance? Maybe a little bit here and there, but not really, right? So you're being paid for this entire thing, but you're only working in this one phase, right? That's a problem. That's a big problem. Let's say you're a BA, a business analyst. You're working your butt off over here, right? In this first phase. System design, you might be providing some input, some, assisting the developers in some way, right? Implementation, development, not really. Testing, not so much. Deployment, maintenance, no, not really. What if you're a developer? Requirement gathering and analysis, you're not really working over here, right? System design, right? Yeah, you're designing that application, right? Creating those wireframes, those mock-ups, the design documents. Implementation, yeah, you're coding the application at this point. What about testing or deployment or maintenance? Not so much, no, okay? And the reason is that these phases don't overlap, right? These phases don't overlap. So in other words, when development is going on, there's nothing else that's going on, right? Only development is happening at that time. It can never be in a waterfall environment that you're developing an application while at the same time some of it is being deployed. That can't happen in a waterfall environment, waterfall methodology, okay? And twiddling our thumbs, yep, that's right. Okay. Example of a project that takes 4 to 5 years. These are generally going to be projects, a lot of times for the government, okay? They have a lot of huge projects, complicated projects that require, a lot of time to be designed and developed, okay? Yeah, in my experience, it's only been government projects that I've worked on that were 4, 5, 6 years long. Okay. Okay. When to use waterfall? This model is used only when the requirements are very well known, when they're clear, and when they're fixed, right? In other words, when they're not changing, right? Product definition is stable and not changing. And this is similar to the requirements being set, being fixed. When the technology is understood, okay? If you are a software development company that focuses on Java development, okay, Java web development, but then this client is asking you to develop an application that's not a web application, but it's going to be a Windows, it's going to be sitting on a Windows platform, okay? And it's a client-server application that you're developing, but your expertise is more on Java web development, right? Then the technology that you would need to implement to create a client-server application, it might not be very well understood. So there's a learning curve there. You have to learn how to create this type of application before you can actually go ahead and do it, right? So maybe waterfall is not the right way to go there. There are no ambiguous requirements. Again, making sure that they're clear, right? As long as everyone understands the requirements, right, then we're good. Ample resources with required expertise are available. So we have enough developers that know how to develop. We have enough testers that know how to test, right? If we have a shortage of resources, then it can cause problems, okay? Also, we want to use waterfall when the project is short, okay? In other words, generally within 1 year, less than 1 year, okay? Any questions on waterfall, or more on waterfall? Customer interaction is minimal during the development of the product. So, customer interaction is minimal. Remember what I was saying up here? Only down here towards the end of the testing phase, right, do we have that UAT, user acceptance testing. That's where the client comes out and actually looks at the application, right? So only at that point in the software development lifecycle or in this waterfall methodology will the client be able to come and see and have any kind of input into the product, right? So customer interaction is very minimal. There's no customer interaction in any other phase other than the requirement analysis phase at the very beginning, right? And then finally at the end of the testing phase, The customer is shown the project only once it's ready to be demonstrated to the end users. Only once that user acceptance testing needs to happen, right? Once the product is developed, if there are any failures, then the costs of fixing such issues are very high, because then we have to go back to the requirement analysis phase, then go through the design, then development, then testing, right? This is because we need to update everything beginning with the requirements. Okay? All right. Now, any questions on waterfall?
Give us an example of about a software which has been used with methodology.
Sorry?
Can you give us an example of a software being made out of using this methodology?
Waterfall?
Mm-hmm.
Okay. So, sometime back, I was working at a company, and this was in the education industry. And they were, I don't know if some of you guys might have gone to school, college over here. There's a website called blackboard.com. Yeah, some of you guys might be familiar with that. So blackboard.com is basically a website where teachers and students can collaborate, right? So teachers can post homework assignments and class notes and things like that online, and the students can download those notes. They can complete activities and exercises online through this application, right? It's just a way for students and teachers to collaborate, to work together online, okay? So I was working for a university, and they were actually developing a interface, a software that's similar to Blackboard.com, okay? But they were using the company's name was Desire to Learn, D2L, okay? Blackboard.com is an American company, D2L is a Canadian company, okay? And so this project, this university that I was working for, they had already implemented a platform in which the students and teachers can collaborate, okay? That type of software was already there. It was actually developed by that university, okay? But and this was actually a very old system, okay? It was a 25-year-old system that was there, and not that long, I think 15 years probably. And what they wanted to do was they wanted to implement this Desire to Learn and bring it over into their university for their students and their teachers, okay? So the project that I was working on was testing the implementation, the development of this Desire to Learn application, and it was slated to take about 3 or 4 years, you know, and it was a waterfall methodology that we were working with. And it wasn't, so when I came there, they were in a waterfall methodology, right? And later on, they actually changed from a waterfall to what's called an agile methodology, and we'll talk about that actually in a little bit, okay? But you know, it just depends. The decision to go with a waterfall methodology or agile or any of these other methodologies, it depends on the complexity of the project, the requirements that are there, you know, the schedules, the resources, the budgeting, all that kind of stuff. All of these factors play a role in determining which methodology an organization would implement. Okay? All right. Yeah, Blackboard is used throughout the United States. Okay. So there is something called V-model, which I'm going to skip. This is why it's called a V-model, because it looks like a V. Okay. But yeah, all that information is described here. Incremental methodology. So incremental, we'll talk about. And I think we'll leave it here. Yeah. Okay. So this is the last thing we'll talk about today. All right. So incremental methodology. All of the requirements are split up into several builds or versions of the application. Okay. we're going to have multiple development cycles take place. Okay, so in other words, multi-waterfall cycle. Okay, what that means, all of those phases of the software development lifecycle will take place. Okay, all of the phases of the software development lifecycle will take place. Okay, but the only thing is, they're going to happen at a much faster pace, right? Because the entire application is broken up into small parts. Okay, so in other words, to manufacture a whole jumbo jet might take a company, a year, right, or 2 years. Okay, but to manufacture just the tail of the plane, right, or just the cockpit, or just one of the wings, or the tires, or whatever, right? Each one of these parts might only take a company, a manufacturing company, a couple of months, right? So we're breaking up the entire application into small parts, okay, in small increments, all right? Cycles are divided up into smaller, more easily managed modules, and each module passes through the software development lifecycle phase. So we're going to have requirement analysis, then design, then development, then testing, and then finally production, okay? A working software of the product is produced during the first module. Each subsequent release of a module will add functionality to the entire application. The process continues until the application is complete. So we have this example here of the Mona Lisa, right? So here we got Da Vinci, right? Thinking up the Mona Lisa here. He's going to first, in the first increment, right, or in the first version, or the first build of this painting, he's going to paint just the top part of this painting, just the face, right? And then in the next build, or the next version, he's going to add to it this bottom left corner, right? This is the next increment, okay, or the next version of this painting. And then finally, the last version is just this bottom right corner, right? And he's going to add it to what was already there, right? And so now at the end we have the complete painting. Does that make sense, guys? Okay. This is a more realistic visualization. So here we have the requirements, right? And the entire application, all those requirements are split up into different builds. Build 1, build 2, and build n, because we can have n number of builds, right? And each of these builds is going to go through that software development lifecycle. So we have the design, we have the development, testing, and then implementation. Again, implementation here means deployment, right? So if for build 1, we have all these phases going on, right? For build 2, we have all of these phases going on of the SDLC. And then for every build, we're going to have each of these phases, okay? Does that make sense, guys? So at the end of build 1, some part of the application is going to be deployed, right? At the end of build 2, some part of the application is going to be deployed or implemented, okay? Any questions so far? Let's see. Challenges of change in regulation or laws. How does waterfall deal with challenges of change in regulation or laws? Yeah, so requirements, regulations, laws, things like that, they do change, okay? And if you're in a waterfall methodology, then, for something like regulations and laws, that force you to conform to certain guidelines, you have to conform to them. You don't really have a choice, okay? So at that point, you would have to implement those changes. And if that means starting over again, then that's what it means, okay? Yeah. All right. So advantages of an incremental model. Yeah.
In this model, does anyone test the compatibility of module 1 to module 2?
Yes. Yes. We will, so I haven't gotten to the testing aspect of it, but we do want to make sure that part 1 is working well with part 2. If it's not, then there's a problem. right? And there is a type of testing there called integration testing. We want to integrate all these different components together. Okay. So yeah, we will talk about that. So advantages of incremental model: it generates working software quickly and early during the software lifecycle. All right. This model is more flexible. It's less costly to change scope and requirements. Think about it. Over here, let's say if the design is flawed for build 1, and we're here in testing, then we come back over here to this part. Okay. What if the development, there was a problem here in build 2? We find it when we're testing build 2. Okay, we come back over here, right? So going back and forth over here, and even if the requirements are changing, right, we can still adapt to it a lot easier than we can with a waterfall methodology, okay? Because everything is split up, right? So we're dealing with smaller portions, or smaller number of requirements, smaller portions of the application. So it's more manageable, right? Does that make sense? Okay. It's easier to test because it's a smaller part of the application that we're testing. We're not testing the entire thing, right? So it's easier to test and debug during a smaller iteration. Iteration just means cycle, right? In this model, the customer can provide feedback with each new build. So whenever there's a build that's being released, right? Remember, there's a build that's being released, right? Every build is being released. And with every build, the client can come back and provide some feedback, right? And if there's something that needs to be changed, we don't have to go back all the way to the very beginning. We just go back to the beginning of this one build, right? Build 2 is fine. There's no problem with it. We just have to go back and work on build 1 again, right? Does that make sense? No? Okay. So build 1 is, let's say, the tail of the plane, okay? Build 2 is the wheels of the plane, right? If the design for the tail is messed up, does that affect the development of the wheels of the plane? No, it doesn't. We can still continue developing the wheels, right? We have to go back and fix the tail, that's for sure. We don't have to go back and fix the entire airplane. Does that make sense? We just have to fix that one part of the plane, right? Does that make sense now? All right. So again, yeah, it's easier to test and debug. Debug simply means to get rid of the bugs, right? To debug. So if there's a problem with the tail, we fix that problem that's there with the tail. We don't need to worry about the wheels or the cockpit or the wings or anything else. Let's see. It lowers the initial delivery cost. This is because, you know, it's a lot easier to manage. We're not dealing with so many high impact bugs all the time, right? We've broken up the entire application, okay? And so we're dealing with problems that come up with just the tail, problems that come up with just the wheels, problems that come up with just the wings, okay? And so to manage and deal with those problems, right, it's a lot easier, a lot faster, a lot quicker, so it costs less. It's easier to manage the risk because risky pieces are identified and handled during each iteration. So let's say we're designing the tail and we have to also design the wheels and develop the wheels. Now, the wheels are really easy, let's say. Like, we can easily do it, it's not a big deal. But the tail is a little bit tricky, okay? So we know that the tail is tricky. We're going to pay a little bit more attention to it. We might add a couple more resources, more developers, more testers, right, to make sure that everything is good with the tail, right? So, you know, we can sort of manage that risk. Okay, the tail is a risky part of the plane in terms of the development, so we're going to focus more and we can manage that risk. Okay. Any questions on the advantages here? Yeah.
So, yeah, how many developer and testers are going to work on one product, like one software?
So how many developers, how many testers? I'm going to talk about these ratios a little bit later on, but really it depends on the project, it depends on the complexity, how big the project is, right? Yeah, it really varies. It really does. Okay, there's no average number of developers and testers. There's no average ratio. Okay. Okay. Let's see. Is it good for long projects? We'll get to that. Okay. What if build 1 is somehow related to build 2, or as we're speaking about the airplane, whole plane may affect the strength of the wheel, or the strength of the wheel might affect the whole airplane. That's right, and there's some testing that would be done. Once the tail is attached and the wheels are attached, right, we're going to test the entire plane. At some point, right, even in this incremental model, before we fully develop and deliver the plane, we're going to test the whole plane out. That's called system testing. Okay, that's called system testing. We're going to test from front to back, top to bottom, front to back, whatever. Okay, we're going to test the entire thing at some point. Okay, and at that point, if we find flaws, then we're going to go back and we're going to deal with it then. Okay. Some of the disadvantages: we need to make sure that we have good planning and design. Okay. Over here, if Da Vinci, if he didn't know what he wanted to paint, he wouldn't know what to put for the first part. He wouldn't know how to split up that painting, right? You have to have a good idea of what it is that you want to be the finished product, right? Because only when you know what it needs to be at the end can you split it up, right? Does that make sense? So we have to have good planning and good design. And that always is not the case. Okay, we may not always be able to have that clear picture of the end product. Okay, in the beginning. Needs a clear and complete definition of the whole system before it can be broken down and built. That's what I just said. And the total cost is higher than waterfall. The reason that cost overall is higher is because we're splitting everything up, right? We're doing the development and the testing multiple times for this project, right? We're developing and we're testing the tail. We're developing and we're testing the wheels. We're developing and testing each wing, right? We're developing and testing the cockpit and the cabin and all that kind of stuff, right? Because we keep doing it over and over and over again, right, we have a lot of repetition. So we have a lot of costs that are being repeated over and over again. Okay, but the quality would be a lot better. Do you guys understand why? Right, because we're focusing on small parts, right, and we're only biting off what we can handle, right? When to use incremental methodology. This model can be used when the requirements of the complete system are clearly defined and understood. So we need to make sure that we have the big picture. We know what that big picture is, right? The major requirements must be defined. However, some of the details can evolve with time. So for example, he knows that he wants to have this painting, right? If it's supposed to be a white lady or a black lady, that can be decided a little bit later on, right? If she needs to have, brown hair, blonde hair, red hair, whatever, that small detail can be decided later on, right? What the background color of this painting is, that can be decided. But we know that it's going to be a painting, it's going to be of a lady, right? These major things are already decided, are already defined. Does that make sense, guys? Okay. There's a need to get a product to the market early. So, for example, we're developing this communication. Going back to that example, that software where two users can communicate with each other. Okay. Let's say that this is something that's really important for the business to get because one department needs to be able to communicate effectively and efficiently with another department, right? And that communication needs to happen right away because right now the way that they communicate is very inefficient and is affecting their business, right? So this is a very urgent requirement, right? So what might happen is we might say, okay, that's fine. Let's build out this interface, right? And give you something that you can use right now. And then as time goes on, we're going to add more and more to it, right? We're going to add more features to this thing, to this software that will enhance your your experience as you're using the software, right? But right now, we're gonna in 2 months we're gonna give you a product that will allow 2 users to communicate with each other. Okay, so that's the first build. The next one will ensure that the communication is secure, right? That it's not that a third party can't come in and hack it, right? Later on, we'll add video conferencing. We'll add the voice features, voice calling features over the internet. All that. We'll add these other things as we go on in different builds, right? But right now we need to send this product to the market right away. Okay. Resources with needed skill set are not available. So let's say, for example, later on we're planning on having the video conferencing, right, for the software. We don't need to have the developers that know that part, that video conferencing interface, how to develop that. We don't need to have those people right now, right? We can hire those people later on, okay, to develop that part of the application or to test that part of the application, right? So we don't need to have that highly skilled resource pool right now, okay? And there are some high-risk features and goals. So again, requirements can change, and that's okay, okay? We can adapt to the change, okay, using this incremental model, okay? This is something that can be used over the long term, okay, this incremental methodology, because like I said, there can be an n number of builds, n number of increments or cycles, right? So this could go on for many, many years, and it wouldn't be a problem, okay? So this incremental methodology is an excellent methodology to have for a longer term project or a more complex project. Okay. All right. So that's all I had today. Are there any questions on anything that we've covered today? Yeah.
So how integration testing out while developing the software?
How does what testing?
Integration testing.
Integration. Oh, how is it done? How is it done?
Yeah.
Okay, so I'm going to go over that integration testing and all other types of testing next week. But to answer your question, you have component A and you have component B. Put them together, right? You already tested component A. It's working fine by itself. You already tested component B. That's working fine by itself. Now you're going to put it together, and you're going to see if both of them are working fine. That's integration testing. That's all it is. Okay? Yes?
Who's going to give the methodology, like by the customer or by the project manager?
So the determination for the methodology is generally made by the higher-ups in that development organization. Okay, I'm talking about executives, the VPs, high-level people at that organization would determine that. But you can have an input. Okay, so when I was working at this university, we started off as a waterfall, right? Later on, we moved to Agile. I was involved in that change, okay, in bringing about that change.
So the developer can change the methodology, right?
Sorry?
The developer can change the methodology.
No individual person can change any methodology. Okay, this methodology is determined based on the environment, based on the projects that are being done, based on the organization. Okay. All right, guys. Before you guys go, I want to show you guys the forum. So. All right, so when you guys log in, you should see something like this. All of my notes, okay, when you come up over here, okay, if you look at class notes, there's a section here, people in tech class notes, okay? Today, we're talking about SDLC, Software Development Lifecycle, so all of these notes, all of these PowerPoint presentations will be found over here, okay? Inside here. This is from the previous batch. Okay. I'm going to post these PowerPoints later on today. Next week when we start talking about Quality Center ALM, the manual testing tool, all those notes would be over here. Okay. People in tech action items given by instructors. This is where that homework is posted. Okay. So for SDLC, it's going to be posted over here. Okay, ALM homework will be posted over here. QTP, when we get there, it's going to be posted over here. Okay.
so you know like how relevant it was.
I'm sorry?
Like where you have like a day post, like today's date, like so you know.
For the homework?
Well, like even like the PowerPoint and everything.
Oh, yeah. So you can see here for the notes for SDLC. I'm sorry, not here. For the notes for SDLC, I usually put the dates whenever I post the notes. Okay. So yeah, the dates will be there. I believe on the videos as well. I believe it's by date. Okay, so you guys can go back and take a look at the dates. I'm sorry?
Those are labs, right?
No, those are the notes.
So I just showed you two sections. I myself work with two of these sections here. The class notes section and people and tech action items given by instructors. Okay? Homework is going to be posted here in the action items given by instructors, and all of my class notes will be here. Okay?
Like whenever you post the homework, we have to get there or just let us know like
So generally, there's going to be homework every Wednesday that I'm going to assign to you guys. This was the first class. I haven't really gone over much, so there's not any homework for this week. Okay. From next week there will be. Okay.
post it here and then we're going to email it to you. Email our.
You're going to email it, yeah, to homework at people in tech, and that email address will also be in the homework assignment itself. Okay, so you'll know about it.
There's one going to be in the for like how I respond to the homework.
Yeah, I'll explain all that when I assign the homework. I'll explain how to submit it and everything. Okay. All right, guys. Good night, guys.
The LA next week, right? The LA is
Okay, 11 is next week.
Are you going to provide it to us?
Sorry?
Are you going to provide it? Like,
I'm teaching.
well,
Yeah.
yeah, good.
Take care. Good night.
No.